Here are the solutions to the second complex fractions worksheet, 1 through 8, but we already did number 2 in the video lesson from yesterday, or from Friday. So let's take a look at number 1. So with this, we need to rewrite everything that has a negative power. So that's both the a to the negative first and b to the negative first in our denominator. So I'm going to leave the numerator the same. Now keep in mind, these are their own little fractions here. I'm not just flipping them up to the top because there's a minus sign here. So the first term in our denominator becomes 1 over a to the positive 1 minus, and then likewise 1 over b. So now I want to multiply by the LCD, which in this case is going to be AB. And what's unique about this is usually at the end I want to factor everything. So the numerator is already factored. I don't want to go ahead and distribute this. So let's just leave it as AB times A minus B. And then what do we have in our denominators? I distribute the AB times the 1 over A. The A's are going to divide out and we're left with B. And then when I multiply 1 over B by AB, that's going to leave me with a minus A. Just keep that in parentheses. Now, yes, b minus a and a minus b are opposites, so when I cross them out, divide them, I'm going to be left with the negative 1. So negative 1 times ab is just a negative ab. Like I said, we did number 2 already together in the video lesson, so let's jump to number 3. Again, I want to first rewrite this as 1 over u squared minus 1 over v squared, and our denominator becomes 1 over u minus 1 over v. Our LCD is u squared times v squared. So as I distribute u squared times v squared times 1 over u squared, the u squares are going to divide out and I'm left with v squared. And just the opposite here, the v squares are going to divide out with the second fraction and I'm left with u squared. So v squared minus u squared. In our denominator, only one u is going to divide out with the u squared here, so I'm still left with the u and a v squared, and then just the opposite, minus, we'll have a u squared and v. Again, I want to factor. The numerator is a difference of squares, so that's going to factor into a v minus u and a v plus u. In our denominator, there's a GCF of uv, and then we're going to be left with v minus u. So yes, the v minus u's divide out, and we're left with v plus u over uv. All right, similar type of problem with number 4. I'm going to rewrite the numerator up here, just stays as an n, and then we get plus 1 over n squared. Denominator becomes 1 plus 1 over n. The LCD is going to be n squared. So now as I multiply n squared by n, that is n cubed. N squared times 1 over n squared will just give me a 1. N squared times 1 here is n squared, and then n squared times 1 over n is going to leave me just with an n. So now I'm going to go ahead and factor. Now this numerator is a sum of 2 cubes, so that's going to factor into a binomial and a trinomial. In the binomial, we'll have an n, same sign, and then a 1. First part, or first term of the trinomial is going to become n squared. Remember, n times n. Opposite sign now, so a minus. Then I multiply 1 times n. Always positive for the last sign, and then I multiply 1 times 1. Denominator, there's a GCF of n, and I'm left with n plus 1. So yes, the n plus 1s are going to cross out, and I'm left with n squared minus n plus 1. That does not factor all over n. Number 5. Again, we're going to start to rewrite. The first term becomes 1 over x squared. This is not a negative exponent, so that just stays minus x squared. First term here becomes 1 over x minus x. My LCD here is x squared. So as I distribute, x squared times 1 over x squared is just 1. Then I will get a minus x to the 4th when I multiply x squared times x squared. Here when I multiply x squared times 1 over x, that's just going to leave me with an x. And then we'll get a minus x cubed. So I'm going to go ahead and factor 1 minus x to the 4th. That is a difference of squares, so I make 2 sets of parentheses. 1 minus x squared and a 1 plus x squared is how that factors. There's a GCF in my denominator of x. When I factor that out, I'm left with a 1 minus x squared. Now, even though 1 minus x squared can factor further, they match perfectly now, so there's no need to factor them further, and I'm just left with 1 plus x squared all over x. Right, now 6 is nothing new like what we were looking at today. This is actually the same types of problems we were looking at the day before. So there's no negative exponents, in other words. So my LCD, I could just determine this right away, is going to be both a plus 1 times a minus 1. So as I go to distribute, multiply by the first fraction, the a plus 1s are gone. I'm left with a minus 1. Here, the a minus 1s are gone. I'm left with plus a plus 1. Down here, the same thing. When I multiply the LCD by the first fraction, a plus 1s are gone. I'm left with a minus 1. Minus, so that means I want to keep the next part in parentheses. When I multiply the LCD by the second fraction, a minus 1s are gone. I'm left with an a plus 1. So up top, we're just going to have a 2a. In our denominator, we have a minus 1 minus a minus 1. The a's are gone. I get a 2a over negative 2, and then that turns into, we could divide out the negative 2's, and the 2's here, I'm left with the negative a. Now 7, there's a couple ways to do this because they're just numbers. We could still follow the rule of multiplying by the LCD, but I'll still show you another way. LCD here is going to be 4. So when I multiply 4 times 2, that's 8. Minus half of 4 is 2. 4 times 1 is 4. Minus 4 times a fourth is 1. So I get 6 over 3, which is 2. Or we could still work with fractions if you want to. Now these fractions are not too bad to turn into decimals either, so we could really say it's 2 minus 0.5 and 1 minus 0.25. We still want to do this without a calculator. So 2 minus 0.5 is going to be 1.5. 1 minus a quarter is going to be 0.75. So if we compared like $1.50 to 75 cents, $1.50 is double 75 cents, so we could just get 2 there. Or you can multiply top and bottom by 100 and say 150 over 75, and that still leads us to 2. But we could see a lot quicker, a lot more efficient to just multiply by the LCD. All right, and number 8, this is a unique case. Again, it doesn't look like the others. We're not adding or subtracting 2 separate fractions in the numerator. What this is a case of one fraction divided by another. So technically what we could do with this a squared plus b squared is put it over 1. Then I could proceed to write it this way. A to the 4th minus b to the 4th over quantity a plus b squared divided by a squared plus b squared over 1. Now I could just multiply by the reciprocal here. So we get a to the 4th minus b to the 4th. Here I'm just going to write a plus b times a plus b times 1 over a squared plus b squared. And I want to factor anything else that can be factored, and it's this numerator here. That's going to factor. It's a difference of squares. A squared minus b squared times the quantity a squared plus b squared over a plus b times a plus b. I can't do anything with the a squared plus b squared, but I'm going to keep it in parentheses because if you notice, it does match here. Now, we're not done factoring, but we can have less to write if we go ahead and cross those out now. And then I could still factor further a squared minus b squared, so I'm going to have an a minus b times a plus b over the 2 a plus b's here. Now only one a plus b from the bottom can cross out with a plus b from the top, and we are left with a minus b over a plus b. No, those are not opposites, so that is our final answer. But if you still have questions over these, feel free to email me, let me know. Take care, guys.